what is H plus ion concentration? That is under root of Ka times concentration. For this kind of question, pH is equals to negative log of normality. For hydroacid, electronegativity and now, welcome back everyone. Today we are diving into the concept of ionic equilibrium from beginning to intermediate level. Let's understand about the basics. In the solid state, electrolytes are bad conductor of electricity. They become good conductor either in molten state or in a solution state. First we understand about what is electrolyte. Electrolytes are those substances that conduct electricity in molten state or aqueous solution. For example, aqueous NaCl solution. Start from the beginning. Ionic equilibrium is the equilibrium established between the unionized molecule and the ions in a solution of a weak electrolyte. Let us start from the beginning. When water ionizes, it gives hydronium ion and hydroxyl ion, H plus or H3O plus and OH minus ion. Ionic product of water is said to be the product of hydronium ion and hydroxyl ion. At 90 degrees centigrade, ionic product of water is 10 raised to power negative of 12, and at 25 degrees centigrade it is 10 raised to the power minus 14. For the pure water, the concentration of hydronium ion equals to the concentration of hydroxyl ion. Now let us start from the pH calculation. What is pH? The negative common logarithmic of hydrogen ion concentration is said to be pH. pH equals negative log of hydronium ion concentration. pOH equals negative log of hydroxyl ion. The sum of pH and pOH equals 14 at 25 degrees centigrade. The sum of pH and pOH at 90 degrees centigrade is 12. When the temperature increases, ionic product of water increases, that's why pH range decreases. pH of pure water is 7 at 25 degrees centigrade and 6 at 90 degrees centigrade. Any solution can be divided into acidic or basic through this pH scale. It lies between 1 to 7, it is acidic, and when it lies between 7 to 14, it is basic. As we grow from 1 to 7, the acidic strength decreases and basic strength increases as we go from 7 to 14, and at 7 it is neutral state. Let us start from the Oswald dilution law. This law states that law of mass action for dilute solution and weak electrolyte, and it gives the relationship between dissociation of weak electrolyte. It is not applicable for highly concentrated or solution of strong electrolyte. Let us consider a weak electrolyte HA that gives H plus ion and A minus ion. At time t equals 0, 1 moles of HA at time equal t, it gives equals amount of hydronium ion and A minus ion. That's why alpha it is 1 minus alpha. If we try to apply the law of mass action, Ka equals alpha square multiplied by concentration divided by 1 minus alpha. For weak electrolytes, alpha is nearly equals 0, that's why 1 minus alpha nearly equals 1, that is Ka equals alpha square of C. Now what is H plus ion concentration? That is under root of Ka times concentration. Hence the degree of dissociation is directly proportional to the square root of its dilution at constant temperature. What is C? C is the concentration. That's why hence of the degree of dissociation is inversely proportional to the square root of its concentration at constant temperature. We can calculate the value of pH by negative of log of hydronium ion concentration, which is under root of Ka times concentration. The smaller the value of Ka or Kb, weaker will be the electrolyte. Remember that. Now the pH solution is only defined for dilute concentration. That is, we cannot consider the pH scale for highly concentrated solution. Now here is a question for you. Does pH of -1 exist? Comment down with the reason. Now concentration is inversely proportional to pH. That is, whenever the concentration increases, pH decreases. For the mixture, you can calculate it by applying volumetric analysis. Now what is common ion effect? It simply suggests that the value of degree of dissociation will be decreased for a weak electrolyte when we add a strong electrolyte sending a common ion. That is, on the presence of common ion, dissociation of weak electrolyte will decrease. On the presence of common ion, solubility also decreases. Let us suppose there is two compound AB and AC. As they share the common ion, that is A plus, then when the A plus increases, the equilibrium will shift backward. That is alpha equals Ki divided by concentration of common ion. Now, here is a super trick of solving any type of solubility problems. I will try to discuss this for our tricks series. Now, for weak acid, Ka equals equilibrium constant for acid, that is P equals to half of pKa minus log H plus ion. For weak base, Kb equals to equilibrium constant for bases, PaH equals half of pKb minus log OH minus ion. What is buffer solution? Those solution that resist a change in pH is said to be buffer solution. For buffer solution, pH equals pKa or pKb plus log salt by acid or base. Now, all the indicators are based upon buffer solution. Buffer capacity is given by change in number of moles divided by change in pH. This is all from the ionic equilibrium. We will discuss about acid-base theory. First, we understand that any substance having pH less than 7 is said to be acidic, and pH greater than 7 to 14 and is said to be base. Salts are the neutralization product of acid and bases. Let us start from acid-base theory. First theory of Arrhenius concept, which is based upon aqueous H plus ion concept, which is like Arrhenius acid are H plus donor in aqueous solution, Arrhenius bases are OH minus donor in aqueous solution. For example, HX, H2SO4, H2CO3, H3PO4 and etc. Exception, BOH thrice and HBO3 is neither Arrhenius acid nor Arrhenius base. Now, second theory related to acid-base theory is Bronsted-Lowry concept. It is based on H plus ion or proton concept. Acids are H plus donor and Bronsted base are H plus acceptor. Or Arrhenius acid are Bronsted acid but not inverse. That is like, or Arrhenius acid are Bronsted acid but not inverse. Now, conjugated acid base, that is like conjugated acid gives H plus ion and gives conjugated base. Conjugated base gives conjugated acid minus H plus ion, that is CaBTH. Conjugated acid base, conjugated base plus hydronium ion. Those species with accepts H plus ion and donates also is said to be amphiprotic series, and which neither accept nor donates is said to be aprotic species. Now, third theory is about Lewis theory, which is based upon electron concept, that is Lewis acid and Lewis base. Lewis acid are those compounds which lacks the completion of octet, that is BX3, AlCl3, BF3, H3BO4. Just remember, H3BO4 is neither Arrhenius acid nor Arrhenius base. Now, cations are Lewis acid. Those compounds having vacant d orbital are Lewis acid. Compound with multiple bond are Lewis acid. For example, carbon dioxide, sulfur dioxide. Lewis base, they have the lone pair atoms. Anion are Lewis base. All Bronsted bases are Lewis base but not on converse. NH4 plus is neither Lewis acid nor Lewis base. Salt are the end product of neutralization reaction. Nitrate salt is salt least likely to be found in any mineral. You can all memorize it by yourself. Now I am going to start about strength of acid and bases. Ionic acid are relatively stronger than weaker acid. Now, aqueous solution of CH3COH content. It is a weak acid, that means it will not be completely dissolved, that is it is slightly ionized. Now, for hydroacid period. For period, acidic strength is directly proportional to electronegativity. For group, it is acidic strength is directly proportional to size. Exception, from going from period left to right, the hydroacid the strength increases. For hydroacid, electronegativity and size. For oxyacid, that is HOZ, across the period left to right it increases, across the group top to bottom it decreases. Acidic strength is directly proportional to number of oxygen. For same compound, that is CO2 is more acidic than CO, HNO3 is more acidic than HNO2, and there is some exception for this rule, that is acidic strength directly proportional to number of oxygens. Now, strength of bases. Conjugate acid. Weak acid gives strong conjugate base and strong acid gives weak conjugate base. For monoatomic anions, basic strength is inversely proportional to size. The greater the electronegativity, weaker will be the base, that is NH3 will be more basic than H2O than HF. For this organic compound, the order of basic strength is diethylamine is more basic than ammonia, more basic than aniline. Carboxylic acid, from going from carboxylic acid to phenol to alcohol, the strength of base decreases. Formic acid is more acidic than benzoic acid than acetic acid. For antacid, NaOH is more basic than MgOH2 than AlOH whole thrice. Now there is some note from ionic equilibrium. KNO3 will not be hydrolyzed. HBO3 is boric acid, is non-protonic acid, it is Lewis acid. The order of acidic strength is for nitrogen oxides. Acidic salt gives cationic hydrolysis and basic salt gives anionic hydrolysis. HCN is amphiphile, that is, it is both Lewis acid and Lewis base. BCl2 is not Lewis acid. Salt of strong acid and strong base are not completely hydrolyzed. Nature of peroxide bond is inversely proportional to acidic strength. For example, here is some trends. Aqueous solution of ammonium carbonate is neither acid nor base. The conjugated base of this compound is this one. I will only discuss about the important question from this paper. pH of buffer solution does not change on dilution. Presence of common ion solubility decreases, and if we decrease it by 10, it will increase by 1 unit. Baking soda is acidic salt. In blood, serum protein act as buffer solution. Aqueous solution having pH 0 is acidic. For this kind of question, pH is equals to negative log of normality. You can get this note for free from our Telegram channel or our Pinterest page. So I suggest you to follow us there. Now that's much for today.